Hello students, a very warm welcome to JEE English by Unacademy, India's leading and largest test preparation platform. Hi Ada, hi everyone, and a very good evening and a very warm welcome to this awesome session. So a little bit of apologies for the delay, I was in the other class. So but anyway, it's going to be super interesting guys, because today we are going to discuss a very easy, trust me, it's the easiest, kind of a topic in finding, electric field around continuous charge distribution. But at the same time, this is something, of course, easy topics is something that are also asked in your exam. So this is also one of the most asked topics in your exam. Okay. Try to understand every single bit of it. That involves a little bit of derivation. A little bit of calculation, etc., etc. You need to understand it and you need to solve it quickly. Okay. Hi Lokesh. Hi. And that being said, students who know me well and good, if not, I am Murlidharan Gopalakrishnan. I completed my MS in Electrical Engineering from one of the top ranking American university. I'm also an IITian who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams. I filed 25 patent applications in India and abroad. And students, if you're not yet on a Telegram channel, do get onto a Telegram channel to get timely live updates on everything that is happening on JEE English. This is something that you want to do so that you can get live notifications, actually not even live, before time notifications on whatever is happening on YouTube, or even any lectures that we conduct on Unacademy special class. Our team conducts on Unacademy special class. So this link is available in the description box below. First of all, you need to download this Telegram app. If you don't have the Telegram app, download it from Google Play Store and App Store and click on to this link. You can just even search us by typing in JEE_English highlighted on the right. And students, this Sunday there would be a special class. This is going to be the second part. If you haven't yet covered the first part, please do cover it so that you will have a clarity. In the first part of A to Z of capacitors, we covered a very important topic, which is around where you are forming capacitors using different kind of geometries. Okay, now we will be probably jumping into the parallel plate side of it, but before that we have a lot of topics to deal with. So don't miss out even a single lecture, and this is the Sunday 11 AM to 2 PM. Don't miss out even a single lecture guys. Very interesting, typically asked topic in your exam and easy. Okay, and it's a free of course special class, so do attend it 11 AM to 2 PM. Don't forget to enroll and attend this class. It's a free of cost special class. And that being said, if you haven't covered units, dimensions and measurements yet on Unacademy learning app, so again a special class from 19th September to 22nd September. Please do cover it because it's easy, less time taking, and you can score easily in your exams. And this is typically, one of the topics where you will get 2 questions or 3 questions, your JEE Mains and JEE Advanced combined, the easiest one that you can ever, learn. Not only that, it's also less time consuming even in your exams. So there are multiple advantages. So 4 sessions were conducted, 4 back-to-back sessions were conducted. And apart from that, guys, we also did an intensive session on different kind of model problems on units, dimensions and measurements. You want to check them out. Alright, that being said, if you haven't downloaded an Unacademy learning app yet, you may want to download it because you will get live notifications on such free special classes. And guys, the amazing thing is not just you'll get just free access to free special classes. You also get access to a quiz feature in which a lot of problems are just the model problems of your PYQs, or it's the PYQs themselves, or typically some kind of problem that are being asked in your exams. So download it. It's available on the Google Play Store and App Store for free. All you need to do is type in Unacademy. You'll find Unacademy learning app, and guys, the most downloaded learning app, and then you'll select this link and install it to get live notifications on many such special classes. So not only that, you can attend your class from anywhere. That's the beauty of Unacademy learning app. And that being said, students, if you are looking for a champion's tool for your JEE Mains and JEE Advanced preparation, we have the best one for you. It comes with everything that you need for your JEE Mains and JEE Advanced preparation. You'll undergo a structured program with the best educators across the nation. And especially when it comes to JEE Mains, we have the best educators. Not only that, we have legends like DC Pandis there on this platform. It's an amazing platform, not just for your learning, but for your preparation to become champions in JEE Mains and JEE Advanced. And you'll undergo an extensive and intensive structured learning program where you'll be attending daily interactive lectures with your favorite educator. Not only that, you can get your doubts cleared from them, and more importantly, you'll be attending national level test series and quizzes, etc. And as such, like every single program that we'll be attending also will have national level test series, quizzes in them. So it's a very a very interesting, very useful, and definitely something which you can leverage for your success in JEE Mains and JEE Advanced. So that's the beauty of Unacademy subscription. And guys, anyway, you are thinking I get access to free of cost lectures, etc. Yes, you do get access to free of cost lectures. We are never denying that, and full-fledged, full quality free of cost lectures. So do share the video and click on that like button and click on that subscribe button and bell notification so that you can get the updates. But the thing is, students, there is a difference between like a test preparation and just attending lectures and learning concepts, etc. and etc. If you're a hustler, you're just learning concepts, amazing. And let's say you're preparing for JEE, you're just using this as an auxiliary tool, amazing. But if you can afford it, this is the best thing that you can have for your JEE Mains and JEE Advanced preparation, because best educators and best platform with the best technology, just like what it gives you the feel of JEE Mains and JEE Advanced. And once you click on to this get subscription button, after clicking on the left hand top corner extension bar, choosing plus, choosing IIT JEE as a goal, and get subscription button there, and then you'll realize another thing, that is, it is one subscription, unlimited access, means you can be enrolling to multiple programs as much as you want. Let's say you're a dropper, you're ready to spend the entire day for your JEE Advanced and JEE Mains preparation. An awesome platform for you. And we have convenient timings. My class happens at 6. Even if you're going to like let's say the lockdown is lifted, you're going to college, you're coming back, still you will have time to attend these classes. So yes, that being said, guys, the price is also very reasonable. It's only going to cost you less than 70 rupees a day, 2,100 per month. So this is less than 70 rupees a day. So, and guys, you get to this price point by applying Murli Live coupon. So do not forget to apply Murli Live coupon to get the best discount on your subscription purchase. And not only that, this program is for 24 months. It's a 24-month program, typically meant for like 9th, 10th, and 11th class students. Okay. So yes, this is the best program for you, and the best thing that you can have. Not only that, students. Hi Shasra, hi. And not only that, students, we have very convenient payment options for you. One of the options that I would like to inform you about is our in-house subscription option, like payment option, which is like pay in parts option, which takes away the burden of paying all the fee at once. So this is typically our in-house feature. This takes away the burden of paying all the fee at once. You can split your payments into multiple parts. We also have no cost EMI. Okay, this no cost EMI is also something that would take away the burden of paying all the fee at once without any interest. So these are some 2 payment options that might be helpful for you. And we also have other traditional payment methods like debit card, credit card, etc. And that being said, if you're looking for a 12-month preparation, we have the best programs for you and the best price for you. And it's going to cost you less than 2,900 per month, only 2,888. How do you get to this price point? By applying Murli Live coupon, you will get the best discount on your subscription purchase. So do apply Murli Live coupon to get the best discount. Do not forget to do that. Never ever miss out on any discounts. And that being said, students, we have 6,000 plus programs for your JEE preparation, 1,000 plus programs which have been just floated last week. And the best thing that you can have for your JEE Mains and JEE Advanced preparation is going to be your Unacademy subscription platform. Okay. So yes, that being said, don't forget to enroll. If you're already on Plus, don't forget to enroll to Optics Basics to Advanced. We have completed the plane mirror to the fullest extent. But now what you need to do is, you know it, I've told you in the lectures, you need to do, you need to go through the lecture sessions, you need to attend the quizzes, you need to do your homework. More importantly, you will be also practicing a lot of problems. Yeah, Sahasra, hi Divya, hi, good evening students. Okay, very warm welcome to this awesome session. So the thing is, enroll to the program. You have this weekend, you have until Tuesday. Complete the lectures, complete your practice. Not just the lectures, but also the practice. If you're already on Plus, and if you're planning to avail, the subscription, do get it and enroll soon. This is the right time, guys. Don't wait for the time the train will leave this station. Okay, the time does not wait for anyone. Okay, if time is the train, it will leave the station. It does not wait for anyone. Enroll soon, and this course was just launched on 9th of October. You can still catch it up, given that you are ready to start this week. So do get started as soon as possible. It is going to be a full extent course for your JEE Mains and JEE Advanced preparation. In terms of optics, we'll be covering from basics, just very basics, to the advanced concepts. And everything, in depth as well. And guys, it's a full-fledged comprehensive course. What do I mean by full-fledged comprehensive course? We'll be not only covering ray optics, as well as we'll be covering wave optics. It's going to be super interesting. It is already interesting, I believe, and there are many smart and really brilliant students who come up with their innovative ways to solve the problems that even sometimes educators cannot think about. So this is the kind of problem, this is the kind of batch that you need for your JEE Mains and JEE Advanced preparation. So enroll soon. It's the best place that you get to learn, and not only that, the best platform you get to learn, and best course to attend. So do attend it, and do remember a simple rule of thumb when it comes to electrostatics and especially electric fields. Practice, practice, and practice, and this will only make you perfect. So you know what you need to do. And guys, do not forget to like the video, do not forget to share the video. That is something that you need to do, because once you share this video, you know what, someone in need may get access to this lecture, and this is going to be a super interesting lecture and a very useful lecture for many. So do share it. It's a free of cost initiative in Unacademy. So do share the video, and not only that, guys, click on that subscribe button and bell notifications so that you can get timely notifications. So let's get into the lecture. Typically a question was asked in JEE Mains along with direction. Okay, I haven't brought up the direction. We'll discuss the direction part as well. What will happen if it's positive, what will happen if it's negative. In this case, this ring is given a uniform linear charge distribution of lambda. Okay, it's given a uniform charge distribution of lambda. Now what you need to do, you need to find out electric field at its center. So yes, students, get started with the solution at the center. Simple one, really simple one. Quite a few times this have been asked, like in one or the other form. We'll be discussing different kind of things that may be asked in your exam. Very simple, guys. Trust me, this is the simplest thing that you're going to deal with. If this is radius r, this is radius r. What should be the magnitude of electric field at the center O? If it was full ring, 0. Symmetry, let's get started then. I believe you can note down the options: k lambda by r, 2k lambda by r, 3k lambda by r, k lambda by 2r. So try to work around it, don't get it wrong. And we also discuss the direction part as we are going to get started with it. So what I'll do is I'll take a small element as usual. This is something that we need to do. This is this is our responsibility. Okay, so this is going to be lambda dx, and now the thing is, you need to find out a simple thing, that is this element. I'll tell you why am I drawing this, and we'll understand something. If we take a symmetrical element somewhere over here, and let's say that we need to assess the field, you'll notice a very interesting thing. Okay, this is only applicable when it's at a symmetrical point, as we discussed earlier. Even the earlier cases, we noticed it's all symmetrical, then it's applicable. The field due to this C point will be like this, and due to B will be something like this. Right, this is one thing and this other thing, but both are positive, so your questions can be in different combination, guys. Half the ring will be positive, half the ring will be negative. It can be a totally negative ring. The arc can be, not 180 degrees, but rather just 60 degrees. It can be 120 degrees, etc. Okay. But first of all, something very important that is typically being asked, that is also very important for understanding, is these side of the components are getting cancelled out. So I'll indicate this with red. We same element, there would be a symmetry. Understood that it would get cancelled out. It's a very interesting model problem. This side and this side would get cancelled out. Only what is left over? The one on the bottom. Right. So there are two components, two similar. If they are same, element, it's going to be basically. So let's label some things. That is going to be theta. Let's this would be some 90 plus theta, etc. Forget that part. We are just analyzing this part. We understood this is the only valid field. This is not the valid field. Hence, I'm going to erase this part. Okay. I'll keep it. I'll erase this. What? Else we won't have the clarity. But I hope you understood that symmetry part, etc., etc. What is happening in that direction? Now, what we need to assess it. What is this field? Do it again. Not k lambda by r. Do it again. Do it again. Do it again. I don't think it is k lambda by r. Okay. It's simple though. You have made a very simple mistake, I believe. So do it again. Check your calculations. You don't have to do it again. Probably. This theta would run from 0 to 180 degrees. Right? Why we are assessing theta, this r is going to be constant. Guys. This radius, it is in the center, going to be constant, and we are only worried about this, downwards component. If this is theta, how much is this? This is also theta. So how much is this? This is sine theta. Okay, I'm calling this as d, this entire field as d, but we know de cos theta is cancelled out due to a symmetrical element. We are only assessing de sine theta. Okay. Now, how do you work around this problem? This is simple. Actually, this problem is the simplest problem, guys, and this is also the most asked one. Literally, I've seen it thrice or four times, different kind of combinations. So this, let's first of all analyze one thing. I said lambda into dx is the element. So this is the kind of charge that is present. But anyway, we will do one thing to make our lives easy. This is going to be what? dq. Sorry. Write it down. This is dq for that field d. So this is the charge for that field. But let me ask you a question. This is radius r. This is theta for some angle theta. Forget that entire, I'll erase this part. It goes from 0 to theta. You understood all of those part. And I'll just keep this part over here. Just let this field be there and etc. etc. This field be there, etc. etc. So this is theta. You understood due to alternating angles, etc. etc. Now the question is, what is dx in terms of r and theta? Isn't it r d theta? Okay, if I take d theta, dx is between d theta element, right? So it should be r d theta for some theta. For theta 1, it is r d theta 1. For anyway, this d theta is the same. So r d theta to etc. 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 Alright, simple. So your dq can be further written as, I'm going to say some charge, linear charge density lambda into dx. Now this will be written as lambda into r d theta. And your net field is what? Vector sign. It's only dey in this case. It's de sine theta, which is how much? K. What is the distance, guys? It's r. R is constant. For any of the element, it's always r. Okay. So did you give out some answer, Divya? Work it out again. Good. You have given an attempt, but work it out again. Guys, so it's a simple problem. I think you missed a small thing. If you're getting 4 and if you're getting 1, you have missed a small thing, I believe. Okay, so just keep noticing what is going right and wrong. So even if I take at some theta 1, it's going to be r, right? R is constant, so it's kq dq rather by r square sine theta. I told you this is the simplest integration we'll ever come across. And I'm going to, you know what, before moving to the next page, I'm going to say d net is equal to k into lambda r d theta sine theta divided by r square d theta. Right? I did nothing, guys. I did nothing. I wrote dq's value r lambda r d theta. That's it. Sin theta is carried over, k is over here, r is over here, r square, and this d theta. Again, I wrote d theta. Okay, that is something that may happen. Okay, that is it. That is it. That is it. That is it. All right. K into lambda r d theta sin theta by r square. Just substitute the value of dq. Okay, let's move on then. It's a simple question. Trust me. This is the this chapter. I mean, like this today's topic is the simplest topic, guys. E total integration of d, which is nothing but k into lambda, maybe something, you know what, you want to remember, and r would get cancelled. I believe r square and r would go off, so it would be just be k into lambda sine theta d theta by r, lambda sine theta into d theta by r. Do you integrate sine theta? Maybe if this is, you know, given in theta or x something, you want to try and convert this lambda into theta. What I mean is, this is a uniform charge distribution case. A question can have non-uniform charge distribution. It can be a function of theta, it can be a function of x and y, etc. But in that case, you try to convert it into theta if possible. Okay, as you saw yesterday, you know, like we did some things to convert it into theta so that our life was easy. Similar things you want to do. Okay, so let's continue with the integration in this case, and I think switch over the ink and let's get started. So what is the limits, guys? It's from 0 to 180 degrees. Integration of sine theta minus cos theta differentiated minus of minus sine theta, so it's going to be basically minus cos theta. K lambda by r would come outside. Integration of, I'll write it down, sine theta d theta. So this is going to be from how much? 0 to pi or 0 to 180 degrees, 0 to pi, 0 to 180 degrees, and k lambda by r cos theta minus cos theta. Okay, 0 to pi. Okay, minus cos theta can be inverted. While I'm going to write it down over here, I'm going to change the things a little bit. Going to be k lambda by r. I think you arrived until here, you probably missed out something, or you have included it twice. You are not going to include twice, right? Even though I told you due to symmetrical elements it will get cancelled. In that case, if you are going to do it 2 de sine theta, then in that case you would only integrate it from very important students. Even when you are dealing with this problem should not happen. Okay, when you are going to just include both the components for the symmetrical element as well, so it's going to be 2 de sine theta. It's not going to be de sine theta. But in that case, you'll integrate from 0 to 90 degrees, not 0 to 180 degrees. Okay. So that is it. So this minus cos theta can be written something like this. When you 0 pi, 0 will become an upper limit. So how much is this, guys? K lambda by r, 1 minus 1, which is nothing but 2. So it's 2k lambda by r. Simple. Now let's talk about the direction. You already understood the direction, but whether your question was around, you know, minus j. So this was given, and there was something like, you know, j cap, minus j cap, I cap, and minus I cap. Let's talk about the direction. Okay. So we understood everything is in this direction, d sine theta direction, d sine theta. What is the direction, guys? Minus, good, minus j cap. minus j cap, right? So here you can add a little minus j cap if you'd like, right? Simple. That is it. I told you this is the simplest thing. Could verify where you have gone wrong. If you have gone wrong, that is more. All right. We'll get into a very interesting question. So given to you, just two charge distributions, like two different kind of charge distribution. Again, uniform charge distribution. Half of the semicircular ring is given positive charge. Half of the semicircular ring is given negative charge. This axis is given x and y. Now, what is being asked is electric field at point O is along which direction? Okay. Simple, students. Try it out yourself. Take a couple of minutes. Think about it. We just discussed how would you work around it, but careful, huh? This is minus. Here you can assume to be some minus q. Don't do the equation, etc., etc. There will be symmetrical elements, etc. Just a hint. Typically, whenever you see in the exam, this is positive, this is negative. So careful. You can also calculate the magnitude. It's not a big deal. And we have done something very similar earlier. Remember, what would be the direction? One way to think about it is, this is a shortcut but not valid. I'll tell you what it is. It is always best to draw the components. So anyway, let's first do it systematically. It's quite easy. So take an element. Going to be over here. Be like this. Let's say this is some d. All right. Take a theta, of course. Again, you'll try to find a symmetrical element on the other side and try to see if you can find out some logic. Do it again. This is minus, right? This is not plus. This is minus. Let's use a different color then. Okay. If this is confusing, let's do a thing. Use a different color. Let me first of all complete this diagram completely. So this is the plus side with theta. It's simple, guys. It's simple. I'll tell you the logic to even think about it, but not not recommended. I mean, fine. It is fine if you can. If you intuit things and not go wrong in the problem, you can use such logics. At the end of the problem, we talk about a small logic. It might sound like very novice logic, but yes, applicable though. Right? So theta. This will also be theta. So I'm just not going to think about theta, but I'm just going to think in directions of x and y. This is dy minus dey. I'm sorry, minus dey. Just giving the minus sign right now. Trying to think about it. And what is this, guys? This is a symmetrical element. Right? This is a symmetrical element. This is going wrong. We draw this. What is this? Now think about from the other logic, that basic logic. Why I told you it could be an easy thing. So this, if I assume to be, sorry, this is where it will go wrong. Okay. We're drawing the line though. Without drawing the line, it's not possible. What is the field? Between this direction. Right? The field is going to be in this direction. This is going to be theta. So probably you already understood what should be the direction, even without me telling you. You already know the thing. So I don't think I need to explain it. Getting it right. Whatever it is, this is theta. No, minus theta anyway. This theta, we are just talking about theta terms. This is how much? dx, negative x direction, right? Just giving negative x direction, not just talking about anything yet. Let's do a thing. I'll give it I cap then. That is more intuitive. Yes, x. Which x? Both x are given to you. Which is that x? Which x it should be? J. Good, good, really good. But which x it should be? This is the direction of this element, symmetrical element, forming some angle theta as well. Okay. What is this direction again? This is the same magnitude. So I'm going to say this is some dE dash y. This also dE dash y plus j cap. This would cancel out. This is also going to be of the same. Negative x, positive x. Think about it carefully. This is negative x. Direction is negative, right? Going from right to left. All right. So what is the direction? This and this gets cancelled out. These both will get added. Cancelled with cancelled. Let me cut it out. Plus a negative. So it is going to be from this direction. Okay. This which direction? If your x-axis is like this, positive x is like this, positive y is like this. This is minus x. Right? Simple. Really simple. Isn't it amazing? Alright, that's all you need to do. Let me tell you something. Maybe it may not be the best thing. Okay, do we have another page? Okay, we'll do it just over here. What I was trying to say is, okay, this is positive, this end is positive, this end is negative. The field is probably supposed to flow like this. Yeah, that's correct. Not C, A, Divya, it's A. We just did it, right? Students, do you have any confusion in this part? This is very important. Now, this is not important. What I am telling you now is not the important part. Okay, but resolving the components is a very important part. I hope everyone understood this part. See, DE due to this element. Similarly, there will be a symmetrical element. Notice this is negative, guys. This can be called as like minus Q and this is plus Q. Don't miss out that part. Right? If so this is positive, field will be flowing away from it, isn't it? Field will be flowing in this direction away from it. I'm talking about this point O, right? So this is D, this is theta, this is also theta. Okay, this is going to be minus some dyj, minus because minus j direction. Okay, and just a moment. Okay, so this is going to be in minus y direction. How about this guy over here? This negative guy will pull the will having the field. It will pull a positive test charge. You can think about it that way. Will have the field in this direction, indicated by the red bar. This is theta, and again forget that theta. This is also going to be dE sin theta, this also dE sin theta, but in opposite direction. So y components will get cancelled out and x components will get added in the negative x direction. It should be clear, students. Not to rewind it and watch it, because this is very important. Okay, all right. The thing is now so I told a small thing that is like, you know what, right hand side is positive, left hand side is negative, so your field should probably flow from right to left. It depends how your charge distribution is. Honestly, this is just something that would only work for this. You don't want to memorize it, you want to work it out and understand which direction it is. And probably even, you know, the first time you draw the fields, you'll understand it. This is in this direction. You do let's call this left off, and I'll do a thing and right off. Sorry, it's a right off. I should be correcting that part. This is right? For me, it's right. So this is left hand side, and left hand side, how is the field? Field is like. Okay, don't make a mistake in this. Okay, this is very important thing. Okay, left hand side field is like this. What would be the net resultant's direction? You can simply intuit it from just drawing these two things. I'm just drawing for, you know, some, like, you know, of this semicircular. Okay, I hope this should be clear. Minus x direction it should. And let's get into the next problem. Okay. So now you have a quarter of a ring, circular ring. We are all talking about circular ring, circular disc, etc., in this entire problem session. So this is again very easy. But do remember there is no symmetrical element, right? This time what is it? You'll have and the charge is only given on the circular part. Okay, this linear part does not matter. If this linear part too has charge, do notice it in your exam. So just a hint for you in the exam, sometimes this can be minus q. If you want to notice such thing, then and there what would you do? If you remember, we did it on the line of rod charge distribution, perpendicular, whatever, like this is not perpendicular case, this is on the line case. If it's low, there could have been a charge distribution on. But we are not talking about the case where there is a charge distribution over here. We are just going to first of all get started with the ring. Yes, it's very easy, very. Angle moves from 0 degrees. Same thing. Theta moves from 0 degrees to 90 degrees. That's it. But there will be two sides of the components. Try it out. It's easy. It's quite easy, guys. Okay. It's quite easy. Let's get started with it. The same thing we need to do. Simple. Draw an element. Draw the field at this point. You need to write down separately for dx. Why would you resolve it? Resolve it. Don't resolve it. It's a vector. You need to resolve it and add each. To each element, there will be an x and y component which you have to add. Let's call this as dx. Let's call this as de. Okay, this is the de, that small field created due to this dx. Okay. Now the thing is, this is theta, right? This is going to be how much? The small element is going to be like what we said earlier. This could be like d theta, the small angle. I hope you are able to see that angle. Else I'll do a thing. I'll just draw it again. That's the concept of this d theta, the small element. Circular ring. Quite simple, guys. Simple. To try to understand that point. And let's intuit in terms of thetas, because thetas is what will help us for this problem. Okay, theta. This is how much. If this entire thing is d, this is de. How much? Sine theta. We'll first of all talk about what is d in this case. We'll begin from there. This will be easy. So this is going to be de sine theta. Dx is d cos theta, right? And this is how much? D theta, the small element over here. And how much is dx? Dx, if you remember, this was radius r. This ring has radius r. And I think I messed it up. Okay. This guy has a radius r. Alright. And this is going to be r d theta. Dx is r d theta. How much charge is present in dx? In dx, how much charge is present? It's lambda into dx. This is lambda, right? Now let's get into the calculation part of it. This is how much, this is the dq. Let's say this is the dq, this is the dq. This element has dq. And now how much is this dq? Lambda into r d theta. Dx is r d theta, that small element width. Over. Now if I'm just going to talk about d, just for a small elemental area at some angle theta, d at an angle theta, d at an angle theta. Okay, how much is it? This is radius r, just the magnitude I'm talking about, magnitude kq by r square, dq by r square. Okay, that gives you k into lambda into r d theta, just like how we did in the last problem. The only difference is there exist two components and you'll integrate it from 0 to 90 degrees. Okay, these things will get cancelled out. It's k lambda by r d theta. Actually, a very interesting thing is going to be this part, guys. d is equal to I think I can pull it up over here. Why? I'll just box it up. You can write it down. If it's not a linear like uniform charge distribution, maybe this is something that you have to arrive at irrespective of anything, because dx is r d theta. Okay, so irrespective of anything, you'll always arrive dE is equal to k lambda by r into d theta. Okay, this is something that you standardly arrive. Just like what we derived in the last class, k lambda by a into something with d theta, maybe something you want to remember. Alright, so two components. So dE consists of I think two components. One is along x direction minus I cap, which we need to integrate separately, and j cap, which we need to minus j cap, which we need to integrate separately. Going to dEy. Okay. What is dEx? dEx is simple. dx is very simple. dEx is, of course, it's along theta, it's dE cos theta. You can substitute the value of dE. dE is k lambda by r. And dy is d sin theta. I believe this is clear. Integrated for sin theta, cos theta, we'll get started with x, we'll go to y. That's it. Simple question, I believe. Alright, I think this is clear. Okay, let's write down d. Let's do it over here. Okay, so this is given to me. Let's first of all integrate for dx. I hope you understood this part. So this should be like, divided, and for all the components you will add dx1, and then if there is something else, then you will add dx2, and you will similarly have dy1, dy2, etc, etc. Just will keep adding it. That's what we are going to do now. Integration. Okay, we had dx is equal to what? D cos theta dE k lambda cos theta. Just substituting values. Okay, let me write it down this way. dE cos theta, which is going to be k lambda by r d theta in the denominator, r square. R got cancelled. If you don't remember that, just to remind you. So that would be k into lambda cos theta d theta, but this is dEx. Alright, there would be a minus sign. You can throw it as minus I. Forget that part for now. Integration of dx is Ex, right? Total Ex. How much is this going to be? This is just integration of k lambda by r cos theta d theta. The theta goes from 0 to 90 degrees, right? This is k lambda by r integration from 0 to pi by 2. 0 to pi by 2. And this is what? Okay, this will become sin theta. You know that. K lambda by r constant. R is always constant. Simple, guys. It's very, 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 very simple. Also one of the asked topic. So why not do it? Okay. So k lambda by r integration of cos theta. So if you differentiate something, it should be cos theta. That is nothing but sin theta from pi by 2 to 0. How much are you getting? K lambda by r. Simple. Were you saying something, Divya? Okay, I didn't notice your message. So let's move on to the next part, which is going to be EY. Total EY is integration of dy. I'm directly writing it down this time. 0 to pi by 2 again. 0 to pi by 2. Okay. K lambda by r. This time it's going to be sine theta. D theta. Okay. Rather simpler, right? EY is how much? Integrated, it's k lambda by r common out. Sorry, I'm like out, irrespective of theta, it's not going to vary. So this is going to be minus of cos theta. Okay, what it is? Just integrate with this part. Minus cos theta differentiated sin theta. And now, what is the limits? I by 2 to 0, I by 2 to 0, it's going to be 1 again. But what is your total field? It's Ex. In this case, Ex, we didn't assign the sign, so it's minus I cap plus of Ey minus j cap. What does that give you? K lambda by r common minus I cap minus j cap. If you remember, this is what we also obtained earlier. Your sign should also be clear, students. Sign should also be clear. Take little time, just try to understand it. Alright, simple. So your E total is how much? In terms of magnitude, you know the direction, it's simple. Okay, minus by minus, how much it should be? Root 2 k lambda by r under root of 1 square plus 1 square. Simple, right guys? Really simple. Please see. Alright, so let's move on to the next concept. Then before that, I'll show you a small thing. So given any arc, how do you solve the problem? Okay, generally there would exist a symmetry. If there is no symmetry, you'll do the thing that what we did now. And let's say your arc at 60 degrees and 60 degrees. This is just for your understanding. You need to understand it. There will be symmetrical components. I've taken this time the arc in this direction. Just try to understand it. You must be getting the right answer. If you're not getting the right answer, guys, just work around it. So what would be the direction of the field? Let's say this is minus, this is given as minus q charge. Okay, so let's take two elements. At this origin is what I have to calculate it. Okay, this at 60 degrees, this also at 60 degrees. So total is 120 degrees. Move on then. Minus q should be like this. Like this. So the field is somewhat towards it's towards the that arc. It's an arc, it's not a complete ring. I'm erasing the 120 degrees part. Okay. Choose to symmetrical. If not symmetry, do this usual thing. One will have field in this direction, the other guy will have field in this direction, and if you resolve for both the symmetrical components, along y direction they would get cancelled out. Agreed? Along x direction it would be added twice, so it's going to be positive x. Okay, positive x direction. I hope this is simple. In this case it's positive x, and minus q when given minus q. Field is flowing towards it. Okay. So simply you would, if not, what would you do? You would add for x, you would add for y, and you would do it. Okay. If not, let's say this is some alpha and this is some beta. What would you do? Forget everything. Start from here. Integrate it from alpha to beta, or you will integrate from alpha to minus beta. Okay. Now, what is dE? dE would always remain same in this case. In this case, dE net is dx. Else you would also write down dEy. Okay. I'm going to call this as theta. This would be the same thing, or d theta. Nothing is going to change. And your angle is going to matter. Forget the alpha beta. I've just given you a hint. If it's alpha beta, how would you work around it? So you not add again field twice. You're only worried about the x component. X component is what? Cos theta. So dx is what we are worried about. And we are what is that? That is going to be d cos theta. dE, you know what you need to do? K lambda by r. d theta. Cos theta d theta. You'll integrate this in a very generalized form. What we can do is including both, x and y. This was like a very symmetrical case. Let's say it was some alpha to beta, something like that. Alpha, beta, two different angles. So then in that case, you can write down, your dE net. You of course integrate it depending upon everything. Any non-uniform charge distribution is given to you. Uniform charge distribution is given to you. Integrate accordingly. We're just going to standardize things. It's going to be dx I cap, and this is going to be dy plus j cap. Let's take this part and understand. Dx plus I cap plus x direction, dy plus j cap plus y direction. Clear? I believe this should be clear. So you would have something like this: k lambda by r sine theta. Sorry, I cap, right? Okay, sine theta should be j cap, depending upon whatever your theta is. Okay. However you take your theta, but integrate your theta accordingly. Cos theta I cap plus of sin theta j cap. Just a standardized form. I did nothing. The one that we derived in the last model problem, just pulled it out and wrote this. Right, this should be clear. Simple. Let's move on to something very interesting. Now, what I'm saying is, until now, what we have been dealing with is like, on its axis, something like that, on its center, like it's, it's radial point, etc. But now what I'm going to do is that we are going to move off this center onto its axis. I mean, it's passing along the center, like through the center, but at some point at x. Little bit of imagination is something that you want to use. You want to maybe get started on this. The q charge is given to the ring. I'll just explain you the question. Charge is given to on the perimeter of the ring, which is nothing but it's given on the circumference. And now they're asking you what is the field at some point x over here. Now the thing is, students, try to imagine a bit. The ring is like this. The ring is, it's like this, and you're trying to assess the field over here. Let's say like this, and you're trying to assess if this is the center. If this is the center of the ring, this is the ring. This is the center of the ring. You're trying to assess some field at this point. Imagine. Fields will be all along, if you take the elemental area at two different points, it will be at also x, y and z. But finally, you can come to a conclusion based on this. It is a case of a symmetrical charge distribution. A symmetrical uniform charge distribution, else this is not happening. Try to imagine things, try to draw it on the notebook, try to imagine things. Very interesting problem, very easy. Literally the easiest problem could be, it's easier than even the earlier one. Trust me, this is easier even than earlier one. As far as the integration everything is concerned, it's totally easy. It's a circular ring, right? It's not an oval ring, it's a circular ring. It's a math based problem. Simple one. There is an interesting phenomena we have to discuss, which is something that is being asked in your exams. Typically, I don't think this is something that can be asked because the integration is very simple in this case. Okay, but there is a very interesting phenomena if you notice this. Okay, something that is typically asked in exam. So instead of that red point, imagine it to be a charge and this charge is being moved, something like that. Okay, there is a very interesting concept around this. It has to be oppositely charged. Okay, I'll come to that point. Alright, let's get started then. What I'm saying is, if I'm going to take an element over here, it will be pointing like this, off this axis like this. It would have some component like this and some component like this. Along the axis, through the center, along the axis, one component would be directing like this. And what I can do is, I can choose another such symmetrical component. Okay, I can choose another such symmetrical component such that one of the fields gets cancelled out. This is a symmetrical component. This would be directing. Okay, let's choose a different color then. That would be more convenient. Okay. First of all, this element got erased. You're understanding it, right? This is not along x or y. There are three axes. There are three axes in this ring, but not very essential. But maybe very essential when it comes to a half charged ring, etc. Then you need to imagine things, guys. Okay, imagination is key. Because this is 2D and we are representing in 3D. I hope you are understanding it some other way. Sounds very easy, right? Actually, integration is far easier than you think. Okay. If I take a symmetrical component over here, what I'm saying is, I think it's taking, and one more thing I would like to mention. So there is if I'm going to say this is an x-axis, this is probably x-axis, then there is also y-axis, there is also z-axis. Think about it carefully. Okay, let's take a symmetrical component and move about it. I'm going to take a symmetrical component like this and move about the problem. Coming from the other side, of the ring. If this is one side, this is the other side. Okay, but this will happen even. This is now we are just dealing with x and z part, but eventually you can also think about x and y part. I'll come to that part. That part is very simple. Okay, so if this is the net field, let's say this is the D. Label it as T. Everywhere we'll label it as T. We need to do that part. If you don't do that, it's a mistake. Okay. So your theta is basically this theta. Theta is forming along with x-axis. Okay. And this will be directed with theta. And this is going to be dE cos theta. Right? I'll come to that part. Don't worry about it. Now it's time to just imagine. Okay. Let's call this as dx and this as 1 dE. Since it's a symmetrical component, magnitude is going to be the same, distance is same. Okay, distance is same at every single point. Think about it. This is a circular ring, this is R. Okay, this is also R and it is at a fixed distance x. What is the distance from this element to here? Under root of r square plus x square. Okay. Now if you imagine this, this also comes out in this direction. It's a symmetrical component. This and this gets cancelled out. And another dEy would be added. If I write it down, I'll just resolve it and write it down over here. Another dEy would add. Any such element that you choose on a ring, there would exist a symmetrical component, and one and only. So best to imagine is these two components generally. It will be like this. I'm going to say this as theta. So R is so one more important thing. This is R. It's given over here, radius R, and this is x. These two are constant. Does that mean theta is always constant? Yeah. If these two are constant, theta is constant, isn't it? Yeah, that's true. Okay. So the problem is quite easy. Don't worry about it. Okay. Now the thing is, uh, I'm just showing you just like a sort of this is something very easy to understand. This is lying on the x and the y axis. So typically one component will be along y, one component will be along x. X will be added up. So field will be like this plus q. This will be added up, and this will be subtracted. Let's y. I'll choose a symmetrical component then. What is the symmetrical component for this guy? Sorry, yeah. So what is dx? First of all, dx is going to be d cos theta. I'll come to that point. It needs to be understood separately. This also going theta. It's going to be theta everywhere. Okay, it's going to be theta everywhere. Now you can solve the problem in leisure, right? This is also theta. This is also same magnitude, same element. This is dx. This is also dx. Right? I'll tell you even a better thing to do in this case. Everything will look constant. It's a very simple case. Very simple. Okay. This is what? This is dy in the opposite direction. This and this will get cancelled. Alright. Now every this other than the x component, all along the circle, all along the space, every other component is getting cancelled out. Very important thing to understand. Imagine things are simple. So I'm only worried about one component. I'm not worried about the vertical side of it as usual. One component is what is only I'm worried about. Now let's get into it and solve it. This is d. This is d. This is dx. How much is dx? Dx is d cos theta. And as I told you, theta is constant. Don't forget it. Theta is constant. Right? This is some distance r. How much is this r? From this element dx, which has, let's say, this dx element has a charge of dq. Charge of dq. I'm not even going to do anything with it. If you notice it, it's a very simple problem. Trust me, guys. R is equal to under root of r square plus of x square. X is a constant. I brought up an x for an intentional reason. I'll tell you why. Because at the end of this, we'll be understanding a very important concept. This may not be, directly asked, but this can be asked in other ways. I'll tell you how this may be asked in exam. Okay, so this is r. This is also something that we can write it down. I'll just, I'll write it down over here. I hope everything is clear. Only along x, we have had a look at it in the space, right? In different spaces and what it looked like. Only cos theta component is left over. That is an amazing thing that has happened to us, isn't it? Right? And theta is constant, guys. Theta is constant. Okay. What is cos theta? Again, something that we want to write down. What is cos theta? Just before proceeding to problem, some basic math kind of things that we want to write down. That is going to be r divided by adjacent by hypotenuse, right? Adjacent is x divided by r, small r. That is nothing but x divided by under root of r square plus x square. Let's come to the field part, which is the easiest part. If I'm going to talk about small field around that point, not considering cos theta, or let's even write down it as det, which is going to be de cos theta, and how much that should be k dq, charge contained in the small element, by r square of cos theta. Let me ask you a question now. Do you think This dq is dependent upon this radial distance. It's a symmetrical circular ring. No. Is it dependent upon x? In this situation at a fixed distance x? No. Really simple. This is going to be k into r, k divided by r square into cos theta. That is the only component left over, and cos theta is also not varying. Cos theta is, since theta is constant, cos theta is also constant. This is constant. Theta is constant. Right? Yes. This is k by r square into x by r. I'm writing down for now as x by r. We'll finally substitute the value. Okay. dq. This is d integrated. Integrating dq will give you q. d total is equal to k into x by r cube into dq. Total field is as simple as, wasn't it the simplest thing, students? Yes. Everything that we have done until now is simple because integration is simple. Basically found the math to be simple. Yes. Because x is constant, r is constant, theta is constant. X, r, theta, for every single element it's constant. Right? Hence it is simple. Understand that point. Okay. dq. And this is r cube. This is kx by r cube. Integration of dq. What it gives you? Q. That's it. That is it. That is all you need to know. Now there is one more important thing that you need to know. You need to observe it. Let me do it. Let me write it down in the other form. Before that, we'll see what is the answer. So kx, kqx, k. We got kx r divided by r cube into q. R cube under root of r square plus x. So probably all of the denominators are fine. Answer should be B. Now let me come to the important part of it. Let's choose a different color. Understand? Okay, there is a concept around this problem which can be asked, which is also asked. So this is like the, forget everything. I'm not writing down et. Okay, let's write down as et. This is going to be in which direction, students? This is going to be in the plus I direction for plus q. Now on the other side it is going to be in the minus I direction. It's going to push it away for a plus q. We're talking about field. Okay, try to understand the point. Talking about field. E total is k into that I think we missed the lambda term. No, don't have lambda. I got confused in that point. It's k by r cube, which is constant. X is also constant. Q is also constant. Just for now, I'm writing it down like this. Let's understand why. So let's say I haven't placed a positive charge over here. I have placed a negative charge over here, and this x is small. It can also be a large one, x small. Now, what I'm doing is I'm taking this negative charge and slightly, displacing it from the rest. What would happen? See, positive attracts negative. If you have difficulty imagining this, assume that ring has negative charge and that charge is positive. Quite simple to understand. It attracts. Okay. Even if not, plus q on ring, minus q over here, opposite direction to the field. Field is in this direction, so your charge will move in this direction. Minus q charge will move in this direction. Okay. Let's do a thing. Right. There's something that can. Let's see. What I'm saying is, if you consider force, which is going to be some test charge, in this case, let's say the test charge is minus q, this is plus q, there is a minus q test charge, and now what I'm going to do is, and I'm just pushing it inside the ring a little bit, in this direction a little bit, okay, so it will go until some point over here, and will start executing simple harmonic motion. It will go until some point, get attracted, move back, come over here, it will go over here, go back, come over here, etc., etc. Okay, I think we have only space over here. So let me explain it again. Okay, it should be displaced a little bit. You understood the field direction, etc., etc. I'll do a thing. Field direction by the plus q charge on this side is going to be like this. This is field direction. Opposite to the field direction, your negative charge will move. Let's say this is a negative charge, and this x is not very large, and you displaced it a little bit along the opposite to the direction of the field. It will move, it will go up until some point, it will get attracted, come back, it will get attracted, come back, it will get attracted, come back, it will execute a simple harmonic motion. This q minus q will execute a simple harmonic motion. Now let's do a thing. Let's write it down in the terms of force to understand something very interesting. That's very, very interesting. This is how, because the derivation is very easy, right? Once you understood the derivation, you can remember even how to derive it. It's quite easy. You'll be able to do it within few minutes. But then there is no this thing in your exam, no sort of challenging thing in your exam. So probably they'll ask you something around this. And a very, 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 very interesting thing, right? So we can actually forget the minus q part of it, but anyway, minus q is important to understand. There will be an SHM. Plus q, probably there is no SHM. Let me write it down. I wanted to change few things over here for understanding. RQ. Now, what I wanted to change was the color of F. Make you understand something. What is that? You understand it, I know, but let's say minus x. What is this? F is equal to kx. Someone asks you time period, you can find it out 2 pi under root m by k, etc., etc. You can do that. You can find out the time period. You can find out the this thing, frequency, etc., etc. So the most important thing to understand was force is k. We got some expression like this. Understand was the constant k. Stations k q minus by r cube, and this is I think this is correct. Okay. This is the kind of spring constant, which will give some frequency, SHM, etc., etc. You can find out now. You can find out frequency, time period, etc. Simple. Work around some problems. You'll notice some problems in your PYQs around this. Try to solve them. I hope this is clear. And do remember, it should be of negative charge. Clear? Even better. Let's do a thing before moving on to the next problem. We have another one simple problem. We'll solve that as well. It's as simple as this. Initially, it looks, wow, a huge problem. Start solving it, you'll understand it's easy. And I believe I don't have to explain you many things now. This is in form. This is in the form. Is equal to. All right. So now the question is the same question. Now they're asking you, where is the field maximum on the point X? Try to sketch the graph. Okay, once you find it out, try to sketch the graph because at certain point the field will be maximum, again it will go down. Okay, field maximum for what? Field maximum for the radius. Okay, it's not field maximum, but it's field maximum for the radius. If you keep changing the radius, if you start plotting a graph with X and R, you'll find some interesting relation. It will go, it will increase, it will reach a peak, it will come down. Okay, it's R versus X graph. But the thing is, for what radius or for what radial distance X, it will have, sorry, I'm really sorry, for what radial distance X, I mean in terms of R, I think I've confused you. Let me come back to this again. So at some distance X, it will have maximum electric field. Okay, and this will come in terms of R. I'm really sorry, that was a wrong statement. Let me correct it. So for some some distance X, it will, depending upon the radius of the circular ring, you will have some, depend upon the radius in terms of radial radius of the ring, there will be a maximum field. And what is it? That is what you have to find. Simple. Let's write down the equation for electric field. We derived something like this, if you remember, kq into x by r, right? Just differentiate it to find out what is the maximum x for which you will get the maximum field value. dE by dx is equal to 0, which says first term kq by r cube, second term, you also actually, if you remember, there is also, what is r? R was under root r square plus x square, right? There will be an x there as well. You can't ignore the r term. Okay, so I think it would have been better even if I wrote it down here like this. A little easier for the understanding, right? So kq x divided by r square plus x square, which is the distance, r over here whole cube. We got kq divided by the x got over, and on the numerator we need to differentiate for the second term, and probably most of you already got the answer. I know that. It's not a big deal. This differentiation is not at all a big deal for you. You can differentiate it and find it out. It's going to be minus kq, constant things, x would remain. And if you differentiate this term on the denominator, it's going to be minus 3 by 2. There is under root minus 3 by 2. So it's going to be minus 5 by 2. Okay. It is minus 3 by 2. So it is going to become minus 5 by 2. And if you differentiate minus 3 by 2, there would also be a 3 by 2. And there would be 2x. Okay. There would be a 3 by 2 and also I'm just carry forwarding the next term and a 2x, right? Isn't it? Yeah. So it would look something, if I'm just writing down this equation little neatly, look something like this: kq divided by r square plus x square to the power 3 by 2. I think now this gives you better clarity. Minus 3 by 2, and there would be an this x and this 2x is there, right? That will get multiplied. So I need not have even written this 2. Let's cancel it out later. This is going to be 2x into Let me correct this part. So I think this is how much? 5 by 2. Now it's clear, right? And you could have also pulled out 3 by 2 outside, and this would just be r square plus x. Okay, this 0, that thing is what? All 0. Simple integration, just like simple differentiation. Do it. 2 gets cancelled, and what I'm saying is the pull out, and first of all I'll take this on the denominator. This is gone. The pull out this term, there would be a minus 3 by 2, 5 by 2 minus 3 by 2, 1. Okay, 5 by 2 minus 3 by 2, it's a 1. There would be an x on the top, x square on the top. It's not x but rather x square. Why? What did we miss out? This x, and there is also an x over here. So there is a 2x square. So what I said was, if you pull out the 3 by 2 and move it on the other side, it will become just 1. This thing would become 1. So what you have? Some equation like this. 3x square is equal to, let me write this part also down, r square plus x square. Okay, is equal to 1. So for some distance x, if you keep assessing according to the radius, it will keep varying at some, depending upon the radius of the ring, it will keep varying. At some radius it will have more, you'll understand eventually that more the radius of the ring, more like like up until more distance you will get maximum field. Take it on the other side, solve it. What does it give you? X is equal to r by root 2. Isn't it simple? 3x square is equal to r square plus x square. So over. Simple one, really simple. But magnitude of electric field will also be maximum at minus r by root 2. This could have been not just plus but plus or minus, because actually what you're getting from here is x square is equal to r square by 2, right? X square is equal to r square by 2. Alright, square is equal to r square by 2. So hence your magnitude of electric field could be maximum at 2 points. One is going to be minus r by root 2 and the other one is going to be plus r by root 2. I hope you understood that point. If both of them are given, you need to mark both students in multiple correct if possible. So think about it carefully. One could be given, etc. And you can similarly also calculate what would be the magnitude of maximum electric field by substituting this term into your kqx by r square. Okay, just substitute the value of this thing, kqx divided by r square plus x square, that is root 2. Okay. Substitute in this, you will find the maximum electric field magnitude as. You try to work around it. Don't ignore it. It's a simple thing that you would do. So don't miss it out. Okay, I think this is clear now. And what shall we do now is we are going to deal with a very interesting. It's an easy one again. Okay, a very easy one, very interesting one. Let's say there's a disk and it has a uniform charge density sigma, areal charge density or surface charge density sigma on its surface. Then the electric field at a point x on its axis as shown in the figure. There's only 3 options I can do because I was not able to accommodate more options. But try to work on your own first of all. Take some time. Try to work on your own. Try to get the answer. And then probably you want to check the method. Because until now you must have had all the clarity of what can be done. You are not worrying about anything. Okay. Try to arrive to the solution. on yourself. But let me tell you, this is very easy. I explained you the ring concept. There is nothing in this. Only one thing would be varying if you understood it carefully. We're going to do some simplifications, of course. This is a part of this entire thing. So that simplifications needs to be done. Okay. So in this case, what is the thing that will be varying? That will be something that will be varying. Okay. I'll tell you what is that thing that is varying. You understood, if I'm going to take a small elemental ring, of course, that's what I'm going to do. Small elemental ring with some thickness. Okay. Small elemental circular disc. Huh? This is a circular disc. Taking a small elemental ring. Now what I'm saying is, in the small elemental ring, what is happening is this theta is varying. Theta is constant all along that axis, all along that circle or all along that ring. That theta is constant with x-axis, but theta as such is varying. Okay, theta as such is varying. This could be a larger theta, angle theta. What I mean is theta is angle. So now this theta is sort of the thing that we need to work around. Theta is varying. X is always constant. This radius is varying. R is varying. But still it's an easy problem. Trust me students, it's super easy. It's pretty easy, guys. Trust me, it's super easy. If you focus, there is nothing in this. R is varying, okay? Call this as A. Let's do a thing. Let's erase everything and just move into the problem. We'll keep the blue one. That ring looks bigger, etc. We'll work with that one. Okay. So you understood now in the case, like, you know what? R is varying, theta is varying. Theta is varying for every small elemental ring. Every small elemental ring. All right. Okay, and theta goes from where to where? Okay, I'll come to that part again. Theta will go from. So do remember, you have already taken the ring. So you need not think about theta going from, over from year to year. Theta is only going from this 0 to here, which is going to be dependent upon the radius of the circular disc. I'll come to that part. First of all, let's write down the elemental equation. This is radius A, right? And what is the sort of area? It's going to give 2 pi a dA, right? This is sort of the area of the ring. Okay. Now, x is constant. X is constant for any, A, etc. R is going to vary, of course. Okay. First of all, let me ask you a question. What is R A in terms of x? A by x is equal to tan theta. This will be the simplest thing that we can do, and this is going to be the simplest method. So focus, it's very easy. Typically, you will find longer methods. You can apply this method and do it very quickly. Tan theta. What is dA? dA is x is constant, guys. Don't forget, x is just a coordinate over here. X is constant. This is going to be x 6 square d theta, and theta differentiated. You can differentiate and do it. Sin theta cos theta. This is one thing that we got. We did this yesterday, didn't we? Yes, we did it yesterday. Do check out yesterday's lecture as well. We did it yesterday, guys. Okay. And one more thing, let me ask you. What is this r? R is under root of x square plus a square. Right? Let's first of all find out what is this x square plus a square. So r square is equal to a square plus x square, where a is x tan theta, x tan square theta plus of x square, which is going to be x square sec square theta. Very simple, right? We got one. And mark it and move around. We did this things, we did this things, we did this things, but this is very simple, guys. Now we got everything we want, and one more thing maybe. What is this? This is surface charge density. What is dq for this ring, students? It's going to be, if I'm going to call this as dA, it's going to be dA sigma, which is going to be 2 pi a dA sigma. Simple until now. If this is not visible, I'll write it down over here, because these are like the basic things we want to first of all derive before moving into the problem and understand. For you, over the time it will become really easy, but maybe we want to derive it initially and understand each and every part. Okay, that is the way. If you and do cover yesterday's lecture, one of a very interesting lecture, one of the most asked topics in electric field as well, but today's lecture is more important. Okay, so this is going to be how much? dA is 2 pi a dA sigma. Right, some things we need to note it. I'll tell you why. Simple thing. Now let's come to the point. Move into each elemental ring. Start calculating electric field. Electric field, you remember we got it as something kq by r square cos theta, which is nothing but kq r square by this is a. You understood, right? This is an elemental ring. Okay. Move on to the math part of it, which is even easier. So from the ring expression, we have something like this: k q x by r cube. Basically kq r square into cos theta, nothing but x by r. Theta, if this was theta, this theta is varying. This theta is going from 0 to some degrees. We'll assess the degrees later on. Okay, that is the thing that we need later on. Now I can say dE, the dE due to this ring, which will be again in x direction only, due to this ring, due to this entire disk, it will be in the positive x direction if this was plus sigma. Else it would be in the other way around. Okay. Now this is going to be how much? It's going to be k into dq into x constant, r cube constant. No, x is constant, r cube is no more constant. Okay, but let me tell you, it is very simple. Just keep focusing. Just keep focusing. Write it down. Write itself. Okay. What is the value of dq? 2 pi a perimeter or whatever radius dA. Okay, what is x? X is x. What is r cube? R cube. R cube. I'll tell you why I'm keeping it as r cube to that point. Okay. Now let's write it down. Move to the next one and substitute the value of a in terms of x. And tan theta, you'll have some things in x tan theta, etc, etc, etc. 2 pi k dA. You remember it was what? First of all, let me do a thing. We have a, and that a needs, okay, I'll just keep this a now alone and this stuff. Now thing is, what is dA? dA was x sec square dA was x sec square d theta. Okay, x sec square d theta. Okay, and what I'm going to do is I'm going to split this in two parts, x by r, tell you why, and the other one is r square. R square, what was it? X square. Let's complete this part of the calculation then. Move on to the next page. It's simple, guys. It's simple. Now I think most of you are moving very quickly if you're watching this video and even started understanding where to move now. Rather a simple integration. This is the simpler form of integration. Okay. Rather other integrations are possible, but you know what, they take time. 2 pi k is Coulomb's constant. A, let's keep this A like this. You need to substitute ultimately the value of A in terms of x, but before that and theta, but before that let's do a thing. Let's start solving this. X sec square theta, what is sec square theta? D theta. Okay, and what is on the denominator? If you remember, r square was what? A square plus x square, which came out to be x square sec square theta. Okay, so sec square cancelled out, d theta would remain, of course, and we also have x to be cancelled out. X by r. Now let me also verify whether the calculations are going correct. We have everything r, 2 pi dA, etc. Sigma is missing, guys. How did we do this? It's absolute blunder, right? Without the charge, we are just doing the math. Okay, sigma is missing somewhere, and let's see this sigma visible. Put sigma there. The sigma. All right. So yes, up until here I think everything is clear, and you also have this x to be cancelled out. Let's cancel it out and move on. Okay, x square cancelled out, x cancelled out. What we have, something like a by r d theta into sigma. Sigma is constant, isn't it? So finally we are left over with a term like this: dE is equal to k into 2 pi sigma. Okay, a by r d theta. A by r d theta. What is a by r, students? There is the cursor. It's a simple one. Trust me, it's a very simple one, and I'll tell you why. Keep watching. This is A. This is what we consider to be A. This A is varying, but we are saying we are going to do everything in terms of theta, because this A is plus quantity. Don't want to deal with A. It creates a lot of headache. The integration is complicated, etc. for many reasons. To deal with theta, we are not going to deal with A. This is R. What is A by R? This is theta. A by R is cos theta. How simple is this integration? Cos theta d theta, this entire thing is constant. Done? Alright. Now, what is dE? dE is just a small elemental electric field, but we need to integrate it from somewhere theta 0 on the axis to some theta. There is some theta. I'll come to that point, okay? To this theta. I think we have space, yeah. So this is a simple integration that we can do, some 0 to theta. Let's say theta is the maximum theta, and this is going to be k into 2 pi sigma integrated cos theta d theta sin theta. Hence, we got over with the problem quite simply. Remember to put it as 0, not minus theta, because you are going from 0 to theta, not minus theta to 0. Sorry, minus theta to, I mean, like, you can go from minus theta to 0, but you're not going from minus theta to theta. Okay. Alright, let's write it down quickly. It's a simple problem, guys. I told you at the beginning itself, today's class is going to be super simple. And this is k into 2 pi into sigma, all constant terms, sine theta 0 to theta to 0, which is nothing but sine theta itself. Some sine theta, this time let's give it a name for the sine theta. Sine theta max, theta max, theta max, and this is also theta max. Limit is theta max. So how much is this? K, 2k pi sigma. Even you can, in fact, if you want, you can remember this thing and simply substitute it, but I don't know whether you want to do that. And if it is, I'll come to the point later. Let's first complete this analysis. First of all, what is it? It's sine theta. We need to find out the value of sine theta. What is sine theta max? Sine theta max, if this is theta max, and this is sine theta max, is our max. This is theta max, sine theta max. How much, students? It's basically the easiest thing you could do. This is r, and r opposite by hypotenuse, r by r max. How much is r max? R divided by under root of r square. I think we did a mistake somewhere, right? Where it is going wrong? Cos theta, that is correct. Zero sign. So it should A by R is somewhere we are going wrong, guys. We are going wrong. Let me come to this point. Let me verify everything. Give me a couple of seconds. Let me verify everything. So yeah, this all is fine, I guess. X square is x square, and 2 pi a d theta, x square is x square. That's all fine. Yeah. dA is equal to x square d theta, and k cube by r cube into x. Okay, this is something that we derived last time, and yeah, we could have kept it as cos theta for convenience. We didn't keep it that way. We just moved on, and we did a this for ring. This is just a generalized form. Okay. K cube again. I don't think anything is gone wrong until now. K into d cube by r cube into x. K into 2 pi a dA into x. Okay, this is all fine. Divided by r cube into sigma. Sigma should be present. Okay. And 2 pi k into a. A came from here. What is dA? dA is x square d theta. We took an r square on the bottom. We added x, and we said that this x would be lost. We do this x square d theta, and this we will left with just a by r. This is also correct. Okay, a by r. Okay, a by r is what, guys? It's not sorry. A by r is. I should not be overconfident sometime. So a by r is equal to not cos theta but sin theta, right? A by r is sin theta. Correct this part, everything is fine. This is the simplest form, and yeah, sin theta. This should be sine theta. Small mistake, created a huge impact, so this is also wrong. Okay, the entire thing has to be rewritten. I rewrite it. A by r is theta. Okay, this is theta max. We can put as theta max. This is what? This is sine theta, and this is going to be minus cos theta differentiated would give you sine theta. Now, what is this? This is k into 2 pi or 2k pi sigma minus theta max. Theta max. It's just this entire thing you can invert the limits, so it's going to be 1 minus cos theta max. Depending upon what cos theta minimum is, you'll start from there. Tell you why am I specifically stating about that thing, because it has a very interesting application again that can be asked. Okay, so yeah, what is it going to be again about? Simple harmonic motion. Let's come to that point. So we are on the wrong track over here. We should be calculating not sine theta but cos theta max. We have moved to cos theta max and we didn't cos theta max. What is cos theta max? Even simpler. It's x by r max. How much is that? X by, what is value of r max? Under root of r square plus of x square, capital R, radius of the disk. This r is radius of the disk, right? That is it. Simple. Substitute the value. You can find out even for the place where it would have the maximum field, etc. E total is going to 2k pi sigma 1 minus. This is just writing it down like that way, but you know what? If you're trying to memorize things, that is the best thing to do in this case. Okay, let me talk about something very interesting, but you want to probably not remember. If you're going to memorize it, a small hint, you don't want to probably remember it in that form, because probably that form does not have any like problem statement for you coming up, etc. 2 pi k sigma, and you want to throw it as cos theta minimum minus cos theta maximum. Minimum would be if there is if you think of it as a disk with some uniform a ring with good thickness. You can state it as ring with good thickness is what this is applicable for. Same thing, right? A disc dented somewhere and made a hole, a circular hole is the same thing. So this sort of gives you an understanding. Even that would be, because everything is going to be in the x direction. If the sigma is positive charge distribution, in this direction it's going to be I cap plus I cap. In this direction it's going to be minus I cap. Okay, this is plus. Simple, right, students? Simple. Don't make any small mistakes like that. It was supposed to be sine theta a by r, and there it went wrong, and the entire thing got messed up. Try it on your own. It's easy. It hardly take 15-20 minutes once you start practicing. But if you're accustomed to it in the exam, it wouldn't take any time. To do it, this chapter is very important. This lecture is very important. So do share this video, do like this video, click on that bell notification and subscribe button to get timely updates. And that being said, students, we already started an awesome course on optics B to A, basics to advanced, Tuesday to Friday, 6 to 7 p.m. Okay, Tuesday to Friday, 6 to 7 p.m. You don't want to miss even a single class. If you are on plus, enroll. Get started. You have the weekend, this entire weekend until Monday, more than weekend, 4 days, only 4 lectures to cover, 5 lectures to cover. To complete it, that would give you a complete understanding of plane mirrors. We have completed plane mirrors, so do complete the entire thing. Watch this optics basics to advanced, which is going to take you from 0 to advanced level. All you need to do is stay dedicated, understand the classes, not just understand the classes, but also understand the advisors around the classes and work accordingly. Your optics will become easy. It's a total comprehensive course. total comprehensive course on both wave optics and ray optics. So do complete it. It was launched on 9th of October, and only 5 classes, just plane mirror, has been completed, but all the topics around plane mirror has been completed for your JEE Mains and JEE Advanced preparation. So do complete it. It's going to be super interesting moving forward. We are also going to get into wave theory. So it's a comprehensive course. So do remember that it's for your JEE Mains and JEE Advanced. It's going to be super interesting. 60 plus lectures, 60 plus sessions with 70 plus different concepts, 500 and odd model problems, so you don't want to miss it out. And if you are planning to get the subscription, get it soon and enroll on the course. And that being said, this Sunday from 11 a.m. to 2 p.m. we will be having super awesome class on capacitors, which is going to be the part 2 of A to Z of capacitors. We have already completed part 1. If you haven't completed it, complete it. There is there is a correlation, but very important topic, guys. So do complete the part 1 as well. It's going to be on Unacademy learning app. It's not going to be on YouTube, so you may want to come over there and attend it. It's a very interactive platform, and it makes your education very interesting. Maybe you want to visit the platform, and it's a free of cost special class. And that being said, guys, do share the channel, do like the video, do click on that bell notification, do practice. Don't forget that practice makes human perfect, and it's typically true in electrostatics. It's a lot of math, guys. So do remember to practice. That will make you perfect. But do also share it so that someone in need may get access to quality lectures. And if they have language barriers, and they are going to get it in English. So do not forget to share this video. Do not forget to click on that bell notification. Do not forget to click on that subscribe button, as well as smash that like button. And that being said, students, work hard and smart to achieve your success. Keep smiling. And that also being said, acquire knowledge and share it. If you're not yet on our Telegram channel, do get onto a Telegram channel, guys. You need to first of all download Telegram app from your Google Play Store and App Store, and then click onto this link that is available in the description box below. That's all you need to do, students. And if you already have the Telegram app, you need to just type in JEE_English. So what is the advantage of getting on our Telegram channel? You will get before the time notifications on any session happening on JEE English, or even on an Unacademy learning app, any classes that is conducted on an Unacademy learning app by our awesome team. If you want to check it out, we have an awesome team with IITians and NITians, head of famous institutions. So you want to get on this Telegram channel and click on that subscribe button. Do not forget to do that. And that being said, students, we completed units, dimensions and measurements. One of the easiest scoring and less time consuming topic. Typically you can expect 2 to 3 questions every. JEE Mains and JEE Advanced back-to-back sessions were conducted from 19th to 22nd September, plus an extra session that was conducted last Sunday. Don't create backlogs. This will not help you. But if you are on track, everything is easy, everything is possible. So yes, typically 2 to 3 questions, easiest topic, less time consuming, and it's available on an Unacademy learning app. So where can you get this app from? Of course, you know it. You need to download it by typing in Unacademy on your Google Play Store and App Store. That's all you need to do, guys. And you will find us the most downloaded education app, impacting more than 7 million lives a day, in a day. And that being said, just click on that install button. Don't hesitate to do that. Not only that, we have free quiz modules, etc. for you. So do download the Unacademy learning app. There are thousands of reasons, but these are some best reasons. You will get live notification on special classes like this. So yes, and you can attend classes from anywhere. And that being said, students, if you're looking for a champions tool for your JEE Mains and JEE Advanced preparation, this is the best thing for you. And what are we talking about? We are talking about an Unacademy subscription, where you have the best educators across the nation on this platform, teaching you and preparing you for JEE Mains and JEE Advanced. And you know what? On an Unacademy subscription, you can also get your doubts cleared from the best educators. And more importantly, it's going to be a very interactive class, as if you're interacting with me in a live session. More interactive, with a very interactive platform, and you can attend questions, etc. Not only that, it's going to be a super structured program that comes along with quizzes and test series. And the entire program is going to be structured. You're going to attend quizzes, you'll be attending lectures, you'll have dedicated doubt clearing session on each topic so that you can maintain completeness in each topic, in each individual subtopic, and that way you can excel in your exam preparation and your problem solving aptitude. So that's the awesome thing about Unacademy subscription. There are many other things, and all you need to do is click on that left hand top corner extension bar and choose plus as your goal and choose IIT JEE as your goal, and then get these subscriptions. One subscription, unlimited access for this awesome champions tool. And guys, you know what? It only costs you 2,100 per month, less than 70 rupees a day, less than 70 rupees a day. And how do you get to this price point? By applying Murli Live coupon. So do apply Murli Live coupon and get the best discount. So don't forget to do that. And whom this is applicable for 9th, 10th and 11th class. So yes, students, and that being said, you know what, if you're looking for a convenient payment option, we have our in-house payment option which reduces the burden of paying all the fee at once. You don't have to go through the hassle of paying all the fee at once by using our pay in parts in-house option. You can also check out no cost EMI, in which you don't have to pay any interest over your EMI. That's also an awesome payment option for you, in which you can split your payment in multiple parts. Maybe you want to also check out payment parts depending upon what you want to do. You also have other traditional payment modes. And that being said, students, also do check out our 12-month subscription program if you are a dropper or long term, and if you only have 1 year for your JEE preparation. So guys, this is also pretty economical, less than 2,900, only 2,888. And how do you get to this price point? By applying Murli Live coupon, you will get the best discount on your subscription purchase. So do apply Murli Live coupon. Don't miss out the best discounts on your subscription purchase. So do apply Murli Live coupon and enroll soon, because this is the time to get started. Because you know what, if you're a dropper or long term, you typically have that 1 year, and most of the programs are posted with a plan to take you throughout the journey. And this is the time, of course, we have programs even in the mid-year, but this is the time, guys. Syllabus is vast, you want to get started now and enroll in the program accordingly. Optics Basics to Advanced is one such course. And not only that, students, we have 6,000 plus materials for your JEE preparation and the best educators across the nation, and also legends like TC Pandey on this single platform. And guys, we have recently started 600 plus live programs. Maybe you want to check them out. So yes, take care, stay safe, bye bye, see you in the next class.